Let us do a review. So if we're trying to find the amplitude, I know that the amplitude is the absolute value of A. If we're trying to find the period, I know that that is 2 pi over absolute B. And the phase shift is negative C over B. And then sketch the graph. So this is A cosine of bx plus c, and then there's a plus 0 here, plus d. Remember that midline, d is often what we refer to as the midline. So here the midline is 0. So in this case, our amplitude is absolute value of A, which is absolute 2, which is 2. Our period is 2 pi over absolute B, so it's 2 pi over 3. That means our step size is period over 4, so that's going to be our period divided into 4 pieces is the same as multiplying by 1/4. So that's 2 pi over 12, which is also known as pi over 6. So each step is going to be pi over 6, and we get 2 pi over 3 as a period. That's our amplitude, so now I'm ready to draw. Well, I know my midline is at y equals 0, so y equals 0, midline. I know that I'm starting at pi. Oh, I didn't do my phase shift. So my phase shift is negative c over b, so it's negative pi over 3, which is pi over 3. That's my new starting place. So I'm going to start at pi over 3. And then from there, I'm going to take 1, 2, 3, 4 steps. Because I think about the quadrants when I take 1, 2, 3, 4 steps. So pi over 3 is my starting point, is the same as starting off with 2 pi over 6. Because now if I take steps of size pi over 6, I'll be at 3 pi over 6, 4 pi over 6, 5 pi over 6, and 6 pi over 6 for one cycle. Move all those out of the way. So now when I'm ready to draw my graph, I know that cosine starts at a peak, because this is cosine, starts at a peak, goes to a midline, goes to a valley, a midline, and then a peak. So it's going to look something like this, where here, since the amplitude is 2, that means the distance from a midline to a peak is 2. From this midline down to this peak is 2. So that means it goes down to negative 2 and up to positive 2. So that's what my function would look like. So then for this function, express it as a sine wave, where we have the least positive number, c. So first, a is the amplitude, or the distance from a midline to a peak. Looks like it's going to be 1, 2, 3, 4, 5. So it looks like a is equal to 5. And again, the way we know that is we would say, since the amplitude is absolute a, well then if we get 5 out, then that must mean that a is 5. Why is it not negative? Because we're going to start right here, and we start going up. And so just like normal sine, we start going up. If here we had started going down, then we would have thought of it as a negative a. My period is always 2 pi over b. How long does it take to make one complete cycle? Well, I can just go peak to peak, or I could go from a 0 to another 0. Here, if we go from peak to peak, it's pretty clear that we take 1, 2, 3, 4 steps going this way. So my period is 4, so we get that 4 is equal to 2 pi over b. That means that b is 2 pi over 4, which gives you that b is pi over 2. Okay, how did I make that one step? Just to make sure that's clear, I multiplied both sides by b, and these canceled out. And so I get 4b is equal to 2 pi, and then I divided both sides by 4 to get to here, so that we see where that came from. So far, I have that y is equal to 5 sine of pi over 2x. And now I just have to figure out what my plus c is. Well, I know that my phase shift is equal to negative c over b. So it looks like my phase shift is over here at -1 because I'm starting off at -1. And so I want to find out what negative c over my b happens to be. Well, then, if I divide by a fraction, that's the same as multiplying by the reciprocal. So I get negative 2c over pi, right? If I keep the top, change division to multiplication, and then flip the bottom, I get that. And then if you, I guess, multiply both sides by pi, how about negative pi? If we multiply both sides by negative pi, we get this. And divide by 2, we get this. So it turns out that pi over 2 is going to be what c is. And I think that kind of makes sense if you plug it in there. So my function is, so y is equal to 5 sine of pi over 2x plus pi over 2. That's going to be the function that makes that picture. Okay. Let's look at the next one, rhythmic process of breathing. So if I look at the rhythmic process of breathing, it consists of alternating points of inhaling and exhaling. One complete cycle normally takes every 5 seconds. So that means that my period is 5 seconds. If f of t denotes the air flow rate, where F is the flow rate in liters per second, and T is, I guess, time in seconds. Then, and it says if its maximum flow rate is 0.6, yes. So that's trying to tell you that the amplitude is equal to 0.6. Then find a formula that looks like this. Well, if the amplitude is 0.6, then that means that absolute A is 0.6, so my A is 0.6. So I've got this 0.6 up front. Sine of, well, if my period is 5 seconds, then that's just telling you that 2 pi over absolute B is equal to 5 seconds. So that's just 5 over 1. But if 2 pi over b is equal to 5 over 1, that means that b over 2 pi is just 1/5. So if you multiply both sides by 2 pi, you get 2 pi over 5 is what your b better be equal to. So this would be the sine of 2 pi over 5 times t. That's going to be your function. All right, I think I might have time for one more. The 6.7 question. So if I look at the 6.7 question, this is from the top of a building that overlooks the ocean. An observer. So give me the next page. So actually first, let me do this. Rip, and take a screenshot, just that much. And I'm going to copy. So when I come over here, add me a new page that's blank. Let's do this problem where we got some more room. So first thing that comes up is we have got the top of a building. So here's a building that overlooks the ocean. So here's my building. It overlooks the water like you do. Here's my building. And here, this observer, I'm going to put him here. I'm going to call this my observer right there. Watches a boat. So here's my boat. Brink, brink, brink. He observes the boat at this point. And then the boat moves a little bit closer. So first he looks out on the horizontal, and he's 100 feet from sea level, which means this is 100 feet. Check. Then the boat changes from a 25-degree angle, which means from the horizontal, you open down 25 degrees to an angle of 40 degrees. So when you open up this way, we get 40 degrees. How far did the boat travel? So we'll call this distance right here, let me make it orange. That is a distance that we'll call D we need to solve for. So I think it should be pretty clear that since these two are parallel and this is a transversal that cuts it, then this and this are alternate interior, so they will be equal. So that means this angle down here is going to be, I'll make it in blue, 25 degrees. Then, since the horizontal and the water, again, are still parallel, if this is a transversal that cuts it, then if this is 40, this angle right here must also be 40 degrees. So this is 40 degrees. So what you'll see now, I'll do that. I will copy all this, and then if you allow me to come down here and hit paste, well, then what happens is you should now see two triangles, which if I use my green, here is one little triangle in green, and then a bigger triangle in blue. So I have two triangles, a big triangle in blue, and a smaller triangle in green. So for the green one, let's see. I could call this distance K if I wanted to. So let's call this distance right here K. So that means the whole bottom of the blue would be K plus D. So the bottom is K plus D is how long the entire bottom is, right? So it's K plus this D over here. And then this we said was 25 degrees. Should be clear that that's 90. This one in here is 40. And then we know that this is 100 feet and 100 feet. So now we're trying to solve for D. So find D. So all of this over here is what we know with this picture and all these labels, and this is what we want. So that should be pretty clear. So if I now write down some true facts, I know that the tangent of 40 degrees is its opposite over adjacent. And I also know that the tangent of 25 degrees is going to be its opposite over its adjacent. So that means that 100 is equal to K, tangent of 40 degrees. That means that 100 is also equal to K plus D times the tangent of 25 degrees. Well, since this is equal to 100 and this is equal to 100, they should be equal. And so I can now set them equal. Finishing up a problem, just tell people to be quiet as they come in. And so if I do that, then I'm going to end up having this and this. Copy. Poop. Paste. Okay. So if I have this and this, then setting them equal, I'm going to have K tangent of 40 degrees is equal to K plus D tangent of 25. It's not the only way to do it, but one way to do it. And so now what you need to do is just distribute here, and you're going to end up getting K tangent of 25 degrees plus D tangent of 25 degrees is equal to K tangent of 40 degrees, right? So if I just knew what K was, I'd be pretty good, right? And so that means when I go here, I get that K tangent of 40 minus k tangent of 25. And you're going to see that I know it here in a second. 25 is equal to d tangent of 25. So that means that d is equal to all this stuff divided by the tangent of 25, right? And so now what I can do is, this is just telling you that k is 100 divided by the tangent of 40 degrees. You can just take that number and plug it in for k here. So your distance is going to be 100 over tangent of 40, whatever that number is. Oh, look at that, times the tangent of 40. So those are going to cancel out nicely. Minus 100 divided by the tangent of 40 times tangent of 25 divided by tangent of 25. That's it. Again, not the most elegant way to do that, but it is one way to do it. I will finish the rest of the review here in just a little bit.